Okay, hi, good afternoon. My name is Kaveh Lahabi, and I'm an assistant professor at Leiden University, physics department.
And I'm Anna. I'm a master student, student at Leiden University.
So, welcome to the session. What we're going to do today is that first I'm just going to give you a brief introduction to the physics program, and then Anna is going to talk about her research, the work she did during her master's studies. And then after that, we will be happy to answer any questions you have. And if you have any questions already, feel free to write it in the chat and we'll get to it at the end of the talk. So if you're here, you probably means that you're thinking about coming to Leiden to study physics. And the main question is probably in your head whether or not you should choose Leiden or another institute. And that is a decision that you have to make yourself. But what we can do today is to help you by first of all giving you some insight about the student experience in Leiden, but not just what's positive, but also what I want to focus on is what makes the Masters of Physics in Leiden unique. And I mean that literally in a global sense. And the answer is probably not going to be obvious to some of you, but we'll get to it. So let's start with just generally the city, Leiden. So Leiden is actually the oldest student town in the Netherlands. And over the centuries, the university and the students have really shaped the way that the town has evolved. And you'll even see it in, if you come to Leiden, if you just go for a short walk, you'll get a sense of that already. And this is particularly true for the physics department, which has been host to some of the biggest legends in physics and some of the biggest discoveries of the last century. And I think you'll probably recognize some of the people in that picture. So yes, the department is very well renowned. It has over 3 Nobel Prizes, over four Spinoza Prizes since the last 2 decades. But why? The department has this renowned reputation, but what does it mean for you to do masters in Leiden? And for that, maybe it's better to have a look at the courses we offer. So as you can see here, it's just a summary of the courses that we have in the master's program. It's a diverse range of different topics, and they're usually taught in small groups by highly skilled lecturers. And a typical class size is somewhere around 10 or 20 students usually. So you'll have plenty of interactions with the professors, and you can even just come by our offices, and we have open doors. So if you're around, you can always come in to ask any questions, have any things you want to discuss. But to be fair, I can't say that this is Leiden is the only place that offers this. You probably can find other institutes, especially if you go globally, that you could offer a similar teaching experience. So no, what makes Leiden unique is really not what happens in the classroom. It's in fact what happens after that. So this is usually happens in the second year of your studies when you start your research project. This is the moment where you transition from student to a full-fledged physicist. In fact, when you start your project in one of our research groups, we don't really regard you as a student anymore. You become our colleague, and you will have access to all the facilities and resources as any member of staff, as a PhD or a professor. But why do we do this? Well, because why do we take our student projects and student research so seriously? Because our research thrives on these projects. We really rely on your creative and intellectual input. And this is, just to show you that I'm not exaggerating. Here, well, here's actually just some of the facilities that our students can play with. But here is more probably relevant. These are actually some of my recent publications, and each of them actually started off as a master's or master's research project. And you'll notice some of the names are highlighted in red. Those are actually all undergraduate students. So I hope this shows you that our students really make a serious contribution to our research. And this has been a system that we've had in Leiden for years, and it hasn't failed us. So to summarize, maybe, I'll keep it short. The reason why I think you should come to Leiden is because it's not because we're the best place to teach you about other people's accomplishments and discoveries. You should come to Leiden because you want to make your own discoveries. And we will do everything we can to help you get there. And that's something I think that, is unique about Leiden, that we take our master's students seriously, and master research is a big deal for us. So I think with that, I'll just pass it to you, Anna. There you go.
Yes, thank you. I'm Anna, and I will tell you guys a bit about my experience as a student in Leiden and about the research I've done so far. So first, quick introduction about me. I could now tell you a whole story about how my choosing process went to choose Leiden, but in all honesty, I had to choose my master's in the depths of Corona, so I just did it where I did my bachelor's. During my bachelor's, I already developed an interest in soft and biomatter, and in Leiden there is a specialization in that, so I chose to do that. I would like to say I took 3 years, but this is my fourth, so I don't want to talk about that part. I took 3 years, and in these 3 years, I did 3 different things. First year, I did my courses. The second year, I took a gap year. And then the third year, I did my research. I will tell you a bit about all 3. So first, the courses, the subjects. There is a whole bunch of different specializations. And like I said, I chose the biological and soft matter specialization. That's one of the experimental specializations, which means that you do actual experimental research. There's also theoretical specializations, and these seem to be a lot more favorable. As you can see here, I put the numbers of how many people there were in my starting year doing this different specializations. I was with 2 others who by now are doing PhDs because they are not me. In the quantum matter and optics, also experimental, there were 4 people, which I think are also all doing PhDs. And then there is the theoretical group that was really, really big. And they had problems finding projects sometimes because it is very competitive. Whereas if you do experimental research, in my opinion at least, it's way more fun. And there is many projects available to do in your second year. But first you have to get to that second year. So you do your courses. There's 2 courses that are mandatory for everyone if you do the theory or the experimental specializations. Those are quantum information and statistical mechanics. In quantum information, I discovered how it feels to be in your 3rd year of high school doing math while you don't want to do it, because there were people there asking me, why are you here? You're doing soft matter. But after I got over that, it was actually quite interesting to do it and to look a bit outside your specialization as well. Then 2 other courses that really interested me that I actually chose to do were mechanical metamaterials, where you look into different types of materials that, because of their structure, behave in ways that you don't normally find in nature. I actually also ended up doing a research project on this subject. And another course I really liked was computational physics, where you learn how to actually set up simulations to help you in your research. And like I said, I started my studies during Corona, so in the first year I couldn't really go to campus. And I took advantage of that opportunity to also follow courses at other universities because, well, I didn't have travel time because everything was online. So I also took courses in Delft and in Amsterdam, which some of the courses were already prearranged with Leiden University and were very easy to take, but others I could find out myself and also just do, and they were approved and are part of my project or my studies. So the program is also very flexible. And then after that first year where I took only courses, I took a gap year where I still stayed at the university as a teaching assistant. I've been doing like TAing, teaching assisting, during both my bachelor's and my master's, but always as a side job. And then I could do it basically full time for a year, which was really nice because in general, working as a teaching assistant is a really good opportunity, which is I want to say master students are encouraged to do it. And because also some of the bachelor courses are in English, it's also possible for international students. But you get to work in your field. You have no travel time because you're already at the university, and you get to know the staff, which is really beneficial for doing projects. Because then you can just ask a professor of a course you TA'd, hey, can I do a project with you? And it's much easier to get started with a conversation than if you only knew them because you took their course or not at all. So that was my second year. And then in my third year, I started doing research. If you're doing an experimental specialization like I do, you do 2 projects. If you don't do an experimental specialization, it's usually 1 and an internship or 1 and a research proposal. One of these 2 projects can be at another university, which I think also gives you opportunities to go abroad, or at a company. But I chose to do both my projects at Leiden University. And now I'll tell you a bit about my first project, which was on a specific protein called FUS. As you can see in the video on the right, this protein undergoes a phase separation. And while phase separations are things we commonly see, for example, if you try to mix water with oil when you're cooking, making a salad, for example, proteins don't usually do this. So this is an interesting property of the protein, but it doesn't stop there. What it also does, if you let it sit for a while, like you can see in the video on the right, that hopefully starts. Yes, if you let it sit for a while, you can see the hours going at the top. It will grow these fibers, and these seem to go from the droplets. FUS, the protein, also exists in the human body, and it exists in your brain. And these fibers have been found in the brains of people suffering from ALS. So it is quite crucial to figure out how and why these fibers grow. And I've been trying to find some clues about that. So what I did, I tried to measure the rate of the fiber growth as function of the concentration of protein around. And with the droplets, with the phase separation, the concentration is really hard to control. So I set up a more controlled experiment where I let the fibers grow of glass beads, which of course don't affect the concentration. So you have more control. So I did that, and these are the results. On the left, you see an image of one of these beads shown in black with the fiber around it. What I then did to measure the fiber growth is draw this bounding circle around the fibers and then plotted the radius of the circle against time, which results in a linear growth profile, as you can see all the way on the right. I did this for a whole bunch of concentrations, which leads to this plot. Here you can see the growth rate as function of the protein concentration. And you can see that on the right, at higher concentrations, it sort of flattens off. And it could be a couple of reasons for this. It could be that I didn't control the concentration good enough, droplets still formed, or that the growth rate is still limited by some other effect, or that there is some systematic error in the way I drew the bounding circles. But this raises some questions about the growth mechanism, and I tried to figure that out. I hypothesized that the fiber can start growing from three locations. It could be that the proteins add at the base, so that the fiber is basically feeding from a droplet, for example, which makes sense if you look at the droplet images or the droplet videos. It could also be that that protein, for some reason adds to the side, or that it adds to the tip. However, if the protein would add from the base, it would mean that we would see much faster growth from fibers growing from droplets, because the droplets have a high concentration, than from fibers growing from beads, because there's no protein in the beads. We don't see this, so it's probably not the base. Another possibility could be the sides, but the sides get bigger as the protein or as the fiber gets bigger, which means that we would see exponential growth. And like I showed you, we saw linear growth, so it's also not the sides. So I hypothesized it must be the tip. So I ran a simulation where I simulated a whole bunch of bead-like proteins floating around in the system, and they would occasionally collide with the surface that I said this is the tip. And I would count the collisions and fit that to, and by varying the size of this surface that I counted the collisions with, I fitted it to the data I had, and that resulted in this fit, where you can see the orange line is a fit to the simulated data, while the blue line is the fit to the experimental data. See, it's a very close match, and the tip area that I needed to simulate to get this close match is very similar in size to the size of one fused protein, meaning that it is pretty likely that it's actually the tip and collisions with the tip that cause the fiber growth, because this just closely matches the tip size. So in conclusion, I found out that likely these fused fibers grow from the tip, so not from the base or the sides, and this was something we had not seen before or had not known before, and honestly, I just did this as a master's project. But fortunately, in hopefully a couple months, when I'm done with my master's, I'll be diving further into this for my PhD, and I'm really excited about that. So thank you for your attention. If you have any questions, please write them in the chat, and Kaveh and I will now also start answering questions.
Very nice. Yeah. Yeah. It's always impressive work. Yeah. Thanks. I knew some of it, but it was still, like, this is cool stuff. Well, we're from very different fields. I mean, I'll do quantum materials and devices, so it's different, but still can appreciate it. Yeah. Good. So the first question. Here we are. Hi, I'm interested in the specialization, cosmology, and theoretical physics. One of my main interests is particle phenomenology. Does Leiden offer opportunity to work on quantum field theory related research beyond neutrino physics? Well, I think, I must say that's probably I'm not the most qualified person to answer that question, because that actually goes way beyond, it's outside my field. So let me see if I understand the question. Does I have opportunity to work? Probably. I think you probably want to get in touch with the professors who actually, are in this field, like quantum field theory, and I think if you email them, they'll be happy to answer you. But it's just that I honestly wouldn't know from top of my head. Good question, though. Yeah. Do you want to read this one?
Sure. Yeah. So the next question is, hi, I'm interested in both the master's physics and astronomy. Both master faculties offer the study cosmology. I was wondering what the difference is in the study between faculties.
Well, I think so. This is probably something that our study advisor could answer in more detail. But one thing that I can tell you is that, well, physics and astronomy, they're just two faculties. So even though there be, you have a lot of overlap, you will basically need to, they have these two faculties have these two institutes have different regulations, and so it's sort of up to you. But I think it's really comes down to which institute and what kind of regulations they have, what kind of package, as a whole they offer. And that's something that you could get in touch with both the study advisor of both faculties.
Yeah,
Mm.
I know one of the general differences between the physics and the astronomy masters is in the layout of the courses and the projects.
Yeah.
Like I explained for my experience with physics, you first do a year of courses and then a year of only research. While for astronomy, because projects usually take a longer time because you're dependent on telescopes or other things, you do one project and 30 EC of courses in the first year, and then also the same in the second year.
Yeah. So, I mean, there's just some regulations that are different. And for instance, I don't know, the way the projects are allocated and so on, there's some differences. And that's why you should look into it to make sure you understand all the rules. Yeah. Good. Now, next question. Is it possible to extend the duration of the Leiden Physics Masters over 3 or 4 years on a part-time basis? Do you know this one?
Well, you can, as in like extend the duration of your studies. However, I don't think there is like an official part-time studies, which means that, for example, if you talk with the study advisor, like already start at the beginning, like, look, I want to take 3 or 4 years. This is my study plan. I just don't want to take the full course load each year. That is possible, but you still have to pay full tuition each year because it's not an official part-time program.
Yeah. So I think it's good to talk to the study advisor. I mean, we'll try to kind of, take these as individual cases, but it's not the standard way of doing it. There's no part-time course that we offer. No. Good.
The next question is it possible to study abroad during the physics master?
Well,
I think it is, but only if you're not already studying abroad, or maybe that's for the bachelor's.
I mean, it depends what you mean by study. So I think there have been some cases I know where the students go abroad for a project, for a research project, but for courses, I think it really depends on the nature of the program and what exactly you're going to study and where and how does it fit in your overall syllabus and courses. Yeah, but again, I think a study advisor would, if you get in touch with them and explain it in more detail, should probably have a better answer. Yeah. Good. So, how many exterior courses is it possible to follow at universities such as Amsterdam and Utrecht? Well, I can basically get started. But I mean, so it is, it is possible in some cases that you follow a course at a different institute, but of course it wouldn't make sense if Leiden offers the same course. So if, for instance, you want to do, solid state physics in Amsterdam, and we're also offering a similar course, then it doesn't make much sense. Again, this is something that really is specific to your track and the course you want to do, and the situation in Leiden and the other institute.
Yeah, there are some courses that are taught in Delft that have already been pre-approved.
Yeah.
So you can just like sign up for those through USIS, which is like the sign up, like the website for those kind of things, and then you can just follow the course. Those are it's mostly course. It's a course on like I think it's 2 courses on living systems, and there is a molecular electricity course or molecular electronics course that you can take in Delft. If you want to take other courses at other universities, that is possible, but like Kaveh said, you need basically this note that Leiden says, yeah, we don't have this. And then you can take it. Like, for example, I took a photosynthesis and energy in Amsterdam, and that is something Leiden doesn't have. So I could do it in Amsterdam, and I also took continuum physics in Delft, which is another course that Leiden just doesn't offer. So that was also allowed. And the great thing about it, it doesn't cost extra money. So that is good. And it's really cool to also experience different styles of teaching.
Yeah. Good. Next one. So, how would you describe the atmosphere, student culture within the faculty, research groups, and study association? Well, I could tell you about. I mean, I'm not in any study associations myself, but I see that people who are tend to also be good friends. So I guess that says something about that. Have you been in any study association?
Yeah, I'm a member of the study association. I mostly went to activities when I was a bachelor student, because over time you develop your friend group. But they also organize activities specifically targeted towards master students, also towards master students who might be new in the at the university. So it's definitely also a way to make friends if you're coming in as a master student.
Yeah.
I also recommend becoming a member, even if you come in as a master student. And overall, the atmosphere within the within the faculty, it's very relaxed. Like Kaveh said, like the class sizes are really small, so you get to know everyone. You get to know your professor also in a much more like closer sense than, for example, a bachelor course with over 100 students. And like especially when you start doing research and you're in a research group, you just become part of the group, and you can like join in their social activities and that kind of stuff.
I mean, within at least I can speak for my research groups. When you start, it's right now I have we have 5 master students and a bachelor students, so it's a sizable group, and I can see they're having a lot of fun. I mean, and I think that is important. Really, it's our research won't thrive if the students are not happy. So, like, literally, half of my job is to, ensure my students are having a good time. Because if they have a good time, if they enjoy working, they're going to be productive. It's just as simple as that. So I'm half therapist at this point, half physicist. But lately I haven't, even had to do anything. They seem to really get along well. They tend to stay late and order foods, and just every week, have drinks in the lab or something on Fridays. No, they seem to like each other. They seem to have a friendly vibe. So, which is good, which is what we want. Yeah. So.
The next question is, could you tell something about the physics and business studies track? What kind of internships are possible? So, the track specifically, I don't know much about it, but I know about a little bit about it. Let's say students who do internships in companies, which is a possibility, but I don't know. Do you know much about the business track in general? Well, I know you do an internship.
Right, is that it? Is that the only difference?
Yeah, basically, like instead of doing 2 projects, you do an internship and a project.
Right. Yeah.
And then, but the question is specifically about what kind of internships there are. And I am not sure. So I think it is best.
Actually, I know. So no, that's actually it's about the internships. I know quite a bit. So the companies that you go work for, they're typically the project would involve some physics, some research. Now, but at the end, so for us, it's important that when you go to a company that uh, we're just not providing free labor. We want our students to also get something out of the internship, that they also, come out with some valuable skills, even if it's not necessarily just physics, but it's important for us that we know that the students are actually growing. So there's many examples with, there's several companies, ASML for instance, one, Cosine. There's several quantum startups that also offer student internships. So it kind of really depends on your preference. And if you find an internship that, you find exciting, then you should discuss it with your study advisor. And yeah, good. So, is there a possibility to do a combined or dual master's and PhD program? Like in terms of combined time period that is reduced in the case of, is that a sort of a US kind of program, you
I think it is, yeah.
Yeah, we don't
So
do that.
like we don't have a combined program. What exists is the Casimir pre-PhD track, which prepares you for doing a PhD. Because you also, what you do then is you do one bigger instead of the two projects, you do one bigger project and then two very small, I think 6-week projects. So you get to dive into a subject, but also look around a bit what you like, and you also write a research proposal already as a separate thing for not necessarily research that you're gonna do within your masters.
Yeah.
So in that sense, that prepares you for a PhD. Of course, it's also possible to do a PhD after a normal masters.
Most of the time, there's normal masters
Yeah,
actually.
most of the time it is.
Yeah. You don't need to be Casimir track, but it's a
No.
good track.
Yeah, it helps.
Yeah.
And then if you were to do a PhD in Leiden as well, it takes 4 years. So then the total combined time of the masters and the PhD would be 6 years.
Yeah.
And I don't think there's any way to shorten that.
No, I mean, because so it's a very different, let's say, it's a very different categories. When you're a master's, you're technically still a student. When you become PhD, you're an employee. So you actually not a student anymore. You get a salary, you pay taxes. It's a different status altogether. So we don't really, if I understand your question, that's not something we offer, no. Were you in Casimir track, by the way? Yeah.
No.
No, you weren't. Right. Okay. Good. How much is a physics PhD focused on education and communication? Well, that really depends on, a physics PhD could literally be. There's like a million different ways that a physics PhD could go. So you could even do a physics PhD that focuses on, science communication and education. That we have that. But apart from that, it really is up to you. So I know a lot of people who, enjoy research but enjoyed education and science communication more, and that is something that they're trying to focus on during their PhD, and then make a career afterwards out of that. So really, when it comes to PhD, there is no one way. It's very different from, let's say, student experience, because what you do with your PhD is a lot of it's up to you. There's no set of courses or anything that you follow. It's literally you have full autonomy on how to manage your time and efforts and resources. So I hope that answers your question.
And in case you meant the education and communication master specialization, I think there again, instead of the 2 projects, you do 1 research project and then 1 internship, I think at a school or something like that. Or even it's only the internship and then you take more courses on education as well. So especially your second year is much more focused on education if you do the education specialization for your masters.
Mm-hmm. So the next question: how to get in contact with a study advisor? Well, you just email her.
Yeah.
So
The email address is studieadviseur@physics.leidenuniv.nl. It's all,
Yeah.
you can also find it on the website.
if you just type in Masters Physics Leiden, it's basically the first thing that shows up. Like any of the pages, her email address and contact details are all there. Okay.
And for the if you have questions about the astronomy track or like about the astronomy studies or about differences between physics and astronomy, you can also contact the astronomy study advisor, whose contact details you can also find on the website.
Okay. Yeah. Yeah. But yeah. No, I mean there's a lot of different tracks and there's a lot of different possibilities, and it's it's it gets sometimes. I mean, for me, it's I have to, it's hard to follow all the tracks at some point because there's so many different ways to basically construct your courses and activities, but it also gives you a lot of flexibility. So I mean, I don't know, for you, what was the, let's say, did you feel like you had enough options when it came to courses? And
Well, I definitely took all of the options with studying at different universities, and I feel like that also really shows how flexible the program is. That you can do, you can even go to different universities. You can do different courses. Also, if you do your specialization, you don't necessarily have to only do courses within your specialization.
yeah,
You're very flexible in how you set up your program, but also how you set up your schedule. If you really want to finish it up in 2 years, the schedule is pretty tight, but it's for certain it's possible. From a lot of people, also I noticed myself that it is less stressful than a bachelor's, although other people say different things as well. But it is also possible to take some more time and have some flexibility in that.
Yeah, no, I see a lot of bank students, the ones in my research group that just take courses a lot of times just for fun. I'm like, but so you have that option. How strongly developed is the theoretical particle physics? Oh God, these are out of my expertise. High energy physics, standard within Leiden over other Dutch universities. Oh, don't make us, rat on other universities. That's mean. I'm not gonna. That's a tricky question. Well, I mean, we know that the theory department, of course, it's very super strong. It have a very high-profile theory department, both in high energy physics, particle physics, but it's the question is like, are you talking about the course or are you talking about research? Because even if it comes to my own research, my own topics, I can't really answer that because it's, especially the higher up you go, the further you go, it becomes, it's not really, it starts, there's no hierarchy. There's not, clear, this is better or bad. I mean, the people do different things. Each group finds its own niche, and they thrive in that. I'm sure some, publish more papers or get more, citations than the others. But generally, the levels, it's very, the quality of research is very high. But it's hard to, compare different institutes and.
Yeah, especially because, like you say, different universities focus on different things.
Yeah.
So I think what might be best to do is just look on the website, look at the research groups that are sort of working in your area of interest, look what they do.
Yeah.
And if that matches what you want to do, then that, in my opinion, that's a better motivation than trying to find sort of this arbitrary best group. But because you can be in the best group and then not do something you like, and you're not gonna have a good time.
No. So really, the thing that I really strongly recommend is that, of course, you want to go to a high-profile group, for your research, sure. But it's not often what you think, the experience you expect and what you end up doing is very different. It's like for me, I personally I was interested, believe it or not, in particle physics. and now, completely changed fields. Like, this was my passion since I was 14, 12. I had particle physics textbooks, even though I didn't understand them. But, and I hated stuff like, oh, magnetism, condensed matter, superconductivity. I was like, oh. But then I started, I don't know, doing research and was like, wait, I'm not going to enjoy doing day-to-day activities and the type of work that goes into that field. I'm not saying that, okay, my field's more fun than the others. Maybe it is, but no, I'm not going to say that. I'm just saying that, you really need to, you don't know what field is the field that you're going to enjoy till you actually do a little bit of a research there. Because, there's a lot of fields that just sounds fantastic. You watch science documentaries and they're just amazing. But then when it comes to doing the actual research, you're gonna probably be disappointed or realize that this is miles away from what you expected. So it's a good idea before you make any serious commitments to explore. See what it's really like to do to do research in that field. And then because it's literally, there's like million different ways and different ways of thinking about the problems and doing things, and you need to find what you're good at and what you enjoy. Okay, do you want to read that one?
Yes, so the next question is there a possibility in contact with the study advisor or teachers to participate in a research half year full-time before starting your master's without getting study credits or such, just to get to know the environment? So I know of a bachelor student, I think he is in his second year now, who is continuing the project I talked about in my presentation, and he's doing that as I think as a student assistant, so he actually also gets paid for it. But for that, you need to be registered as a student. And I feel like that is the only way, because otherwise would just sort of be unofficially hanging around in a lab, and that doesn't sound like something that you want to do also. So it is possible, I think, but then you have to be registered as a student.
I mean, it's well, I personally, if you just ask me if it was just me, I'll say, yeah, let's do it. I just think you're ready to do research literally right after your bachelor's even. But I think it's, it's important to actually just make sure that you're on a track and you don't kind of get just sidetracked with various things. So once you have a master project, I mean, there's some time limits and things like that, but overall it also helps you kind of stay focused and not lose track and focus on one project. So I don't know why you would want to do that, but again, it's probably I wouldn't recommend it, but it's something you could you could discuss with the study advisor, and also if you know any professors who are interested in offering that sort of position, maybe.
If you're considering doing this because you're worried you won't get enough research experience, that you don't need to worry about that.
No.
You'll be doing a full year of research for your master's, which is also a lot compared to other universities, I think. Yeah.
No, we do 4 months and 6 months, and sometimes even students sometimes even do summer internships, something like that, But compared to other universities, at least in the Netherlands, they're it's very short. So it's like sometimes I personally not a big fan of 4 weeks research projects, or 6 weeks research projects. Like, you can't really make any contribution that way. So as soon as you just figured out what's what, you have to write a report. Which again, maybe you like that, but again, for me, that's more still in the student mode, because you're not really, it's just impossible to make a meaningful, substantial contribution within that short period of time, regardless of how, clever and hardworking you are. So this stuff takes time, and I think, long projects, let's say 4 or 6 months, is definitely, you know, at least 4 months is actually. Well, I would have
The
started.
4 month project still feels short.
It does. It does. Yes, I'm a big fan of 6 month projects.
That's why I'm taking 6 months for my 4 month project.
Yeah. That's the study advisor. No.
Maybe.
Okay.
Next question.
Is it possible to take any business elective course from physics and business studies, masters, even if one might be enrolled in another master's?
I think for sure you can just do it. And then, like, if you just want to follow it out of interest, you are free to just sit in on the classes. I'm pretty sure you can take the exam or anything. What I'm not sure about is, but you just have to discuss that with the study advisor, if it could count towards your credit. In case it doesn't, you'll just be doing some more credit because you still need to get your credits towards your specialization from somewhere else. So you'll be doing more work, but it's for sure it's possible, and it might even count towards your other towards your other specialization, because I think you're allowed to do some stuff outside of your specialization.
Yeah. No. Good. Is there another one? Okay. Well, I think there's a bit of a and all if there are any. Okay. Oh, Thomas. Thank you, Thomas. Yeah. Good. We're what time we are supposed to?
I think it is until
4:30.
Yeah.
Oh, 4:20. Oh no.
4:20. Oh, so if
3
you
minutes
have
late.
one more burning question, I think we can answer it.
Yeah, or doesn't have to be burning. Also, you could just.
Yeah. So if you just want.
We just like to hear
answer a
from you.
question.
Yeah. Anything. Yeah. But well, I think. I mean, we'll see if there's any questions comes up in last couple of minutes. But yeah, I hope this was useful, and you're always welcome to, of course, email us about research or so. I would suggest that if you're really, interested in a specific specialization, for instance, I don't know, neutrinos or quantum field theory, that you email also the professors who work on that topic. It's good to, I did that when I was a student, actually. You could always email them, say you're interested and what do they recommend. So it's good. So it's not just your study advice. A lot of times you could also just get in touch directly with the professors who might know more about the actual scope of their research, and if they have projects they can offer you and what kind of projects they can offer you. I remember when I was applying for a master's, I would just contact the professors directly and say, hey, if I came to, your institute, can I do my master's project with you, and what kind of research I'll be doing? And I think and they were always, I almost always got a response. So it's, I think, a lot of the questions, if it's about the physics, about the research, I think just get in touch with the professors. If it's about programs and courses, get in touch with the study advisor. Yeah.
Yes.
Good.
Also, a little. Oh, there's a question.
What are the prospects for continuing research at a research facility, e.g. CERN or something similar, after masters and or after a PhD? Well, that really depends. Depends on how well it goes. So after masters, it depends on what levels you want to work at these facilities. I think with a PhD you have more options, and also with a PhD you have more. You have a better overview of basically what is really involved, because again, CERN is there is a million different types of work that you could be doing in CERN. Or any of these other institutes. So if you do a PhD and you do well, basically you could aim for anywhere. There's literally nothing stopping you. Yeah.
Yeah.
Yeah. Good. think, are there any more questions? No? Okay. Very good. I think our time's up. Well,
Thank you for your attention, and well,
hopefully we'll see you soon.
Yes.
Yeah. Good.